we have the first question here, trying to talk about a kind of titration reaction where a student tries to prepare potassium sulfate crystals by mixing potassium carbonate and dilute sulfuric acid, right? So all of this information are here. Then you're asked to fill in this space in the question. So all you just need to do is to use your calculator, do the subtraction, right? The final burette reading is 18.8. Initial burette reading is 4.2. By the time you subtract that, you have this as the answer. So 14.6 is the answer to that, to get the 1 mark for this question. All right. The next question says state which solution, either the aqueous potassium carbonate or dilute sulfuric acid, is the least concentrated. Now, if you look at the description of the question, you see that this is the volume of potassium carbonate you're expected to use, which is 25 centimeter cube. And then by the time you're done with your titration, this is the volume that at the end point, this is the volume of acid you need to titrate 25 centimeter cube. So you'd see obviously that 25 centimeter cube is a larger volume compared to 14.6 centimeter cube of sulfuric acid. And what does that mean? It means that the potassium carbonate is the least potassium carbonate because it has a larger volume when you compare it to the volume of sulfuric acid used. Right, so that is how to determine that. Okay, so name a piece of apparatus suitable for measuring 25 centimeter cube of aqueous potassium carbonate. Now, since 25 centimeter cube is an exact volume, the most suitable apparatus would be a volumetric pipette. Remember that pipettes measure exact volumes and they are very accurate. Name a suitable indicator and give the color change of this indicator at endpoint. Of course, the common indicator is methyl orange. And by the time you add it into the conical flask containing the potassium carbonate, it's going to have a yellow color because potassium carbonate gives the basic, it's more of the basic solution in this reaction. Remember that this is basic and this is the acid. So it's going to have a yellow color in the conical flask. And by the time you titrate with the acid, move to the neutral color, which is orange. The next one says, as the student added the dilute sulfuric acid to the aqueous potassium carbonate, he looked for a color change. State what the student should do as they add. So basically, as you're adding the acid, what you simply do is to swirl, not shake. Okay, do not write shake. You swirl the content of the flask gently until you get to the end point. So that is for that. So quite easy questions. Now, the next one says, describe what the student should now do to obtain crystals of pure potassium sulfate. Okay, so since the student now understands what volume of acid is needed to neutralize the potassium carbonate, what the student can simply do is to measure 14.6 centimeter cube of dilute sulfuric acid and 25 centimeter cube of the potassium carbonate used. Mix them together into quantity, heat the mixture to point of crystallization. So the student can heat the mixture to point of crystallization. This point is extremely vital when you're talking about obtaining crystals. Sometimes students just write heat the mixture. No, you won't get the mark. You don't just heat the mixture. You have to heat the mixture to the point where the mixture begins to crystallize. Don't just heat it to dryness. Okay, you heat it to the point where it starts to crystallize. And after that, you leave it to cool so that the crystals can form well. Then you wash with distilled water and you dry in between filter papers. This is the way you could obtain crystals of pure potassium sulfate. Right, and that brings us to the end of question 1. So you can see that they are quite familiar questions. Right, so let's go to question 2. Now, in question 2, you're given a description, kind of a description where a student is trying to investigate the rate of reaction as it depends on the concentration. So, a magnesium ribbon was used with dilute acid, and the concentrations were observed. Okay, it was observed at different concentrations, basically. And then one thing we also notice in this description is that the acid was changed. Okay, we had to change the acid at different experiments. Now, the student does 5 experiments. This is the volume of the acid that was used. So you use a measuring cylinder to pour 30 centimeter cube of the acid into a conical flask, and then a coil of magnesium ribbon to the acid in the conical flask, and immediately the stopwatch was started. Okay, so for experiment 2, these same steps were repeated, but a different acid was used, the same volume, different acid in experiment 3, different acid in experiment 4, and another different acid in experiment 5. All right, so let's go to the table. All right, so we have a table here to read up to complete the time for magnesium to disappear in seconds. So, okay, so we have the concentration already there. So we have to use this, using the stopwatch diagram to measure the time. Okay, you were already told that the outer circle represents seconds, and you were told that the value must be in seconds. So by the time you read this, you see that each of these lines is simply representing 1 second. So it's like 1, 2, 3, like that. You keep on counting the lines. And by the time you do that, we have 20 seconds here. By the time you do that for this, you also have 25 seconds here. Remember, this is on 0, so you're not going to factor this in your calculation because it's pointing to 0. What you focus on is on this long and. So by the time you do that accurately, you have 25 seconds in the second one, you have 42 seconds in the third one, you have 56 seconds in the fourth experiment, and we have 95 seconds in the fifth experiment. Okay, so basically you can see that there is a change of the shorthand this time in terms of minutes. So you have to convert minutes to seconds, and then you obtain that. All right, so after completing the table, let's see what next. Then you ask to plot, right? We have to plot the time taken against the concentration of acid. So this is what we have. We have 5 plots here. So this was what we obtained after plotting. And then you're asked to draw the line of best fit, basically. So this is my line of best fit. It is able to cut across 2 points out of the 5 points, which makes it good enough. All right. And this is what you have to do to get the graph. Okay, we don't have to force any points into the line of best fit. Okay, so it says now from your graph in figure 2.1, deduce the time for the magnesium to disappear when the concentration of the acid is 1.3. So all you just need to do is to go to your graph. Remember that on the x-axis, you're looking at concentration. 1.3, this is 1.22, 1.24, 1.26, 1.28, and this is 3. So we trace 3 all the way to the line we drew. All right, and it's simply touching here, and we trace it all the way to the y-axis. Just going to draft it a bit to see what we have here.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E-levels as well, and also for the Edexcel. So we have for the Cambridge E-levels and Edexcel E-levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E-level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time, even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com and they'll reply to you.
Okay, so for my trace, it took me to this point. So from this whole thing, each line represents 3. So let's count 1, 2, 3, 4, 5, 6, 7. So 7. So that's 7 times 3. That's about 21. So I'll just come in here and fill 21 seconds. Okay, so you have to show this on the graph. Very important. So you have to use this to extrapolate this data, showing it on the graph. All right, moving to the next question. The mean rate of the reaction is calculated using the equation. So the mean rate of reaction is the length of the magnesium ribbon in centimeter divided by the time for magnesium to disappear in seconds. All right, so we're told that the length of the magnesium ribbon is 5 centimeters. So calculate the mean rate of reaction in experiment 1. Give units for the rate you have calculated. All right, so we already know that the length of the magnesium ribbon is 5. So divided by the time for magnesium in experiment 1 was 20. Check your table. So by the time you compute that, you have 0.25. And of course, look at the unit, centimeter per second. So centimeter per second. So that is how to solve that particular one. Using which experiment is the mean rate of reaction the slowest? The one that takes the longer time is the slowest. And if you check, you see experiment 5 has a longer time of about 95 seconds. So it is the one with the slowest rate of reaction. All right, explain why repeating each experiment is an improvement. Of course, you need to repeat experiment so that you see how reproducible the results are. So you will be able to compare. So you do that so that you compare the results and observe which one is an anomalous result. So in order to have concordant results, that is why we need to repeat experiments, basically. Now for F, the student does another experiment to find the temperature change when magnesium reacts with acid A. All right, so basically you have all the information there, no waste time reading them. So we go to the reading on the table of the thermometer, basically. So you check the reading here. So each unit here is 1, so 21, 22, 23, 24. So I have 24.0. You do this also, you have this reading in between 46 and 47. That is why we have 46.5. Take the difference, you have 22.5. Now you observe that all the readings here are reported in the same decimal place. This is very important. Okay, always ensure that your readings are in the same decimal places. To explain why controlling the temperature of the acids so that it remains constant is an improvement. Because when you change the temperature, remember from your knowledge of rate of reaction, when temperature changes, it affects the rate of reaction. So you need to control the temperature because the temperature has a great effect on the rate of reaction. Explain why using a polystyrene cup instead of the 100 centimeter cube conical flask does not control the temperature of the acid. Okay, so the polystyrene cup only prevents heat loss. Okay, it only prevents the rate at which heat is lost. Okay, it doesn't control the temperature. It doesn't keep the temperature constant. It only prevents heat loss and regulating the way heat is lost. All right, so describe how the temperature of the acid can be controlled and kept constant. So if you want to keep the temperature constant, use a water bath. So water bath, you have it's automated for you to fix a particular temperature and it will remain that way. Okay, so that is a way to keep, that is an improvement of the polystyrene cup. So the water bath helps you keep the temperature constant, while the polystyrene cup just help you prevent heat loss. All right, and that ends that particular part of the question. Okay, so we go to question 3 now. Now, a student tests 2 solids, F and solid G. The student adds 15 centimeter cube of dilute hydrochloric acid to the sample. Now look at this solid F, calcium carbonate, that's calcium carbonate. This is the formula of calcium carbonate. So you have a question like this where you have a table to use for the test of ions. You should know that the question will either be asking you to test for calcium or you'll be asked to test for carbonate. That is just the what you'll be expected to do. Okay, so the student adds 15 centimeter cube of dilute hydrochloric acid to this sample. And whenever you're adding an acid to a carbonate, of course, you know that you are testing for the carbonate. So, and test any gas produced. So, what would happen? The observations will be after you've added the acid, what will happen is that there will be bubbles, or you could say there will be a effervescence. And that is the first thing you need to state. The moment you add an acid into a carbonate, you observe a effervescence. That is, the bubbles of a gas will be giving off. And then how do you test that gas? You use lime water. You test the gas with lime water. The lime water turns milky. So this is how to get the 2 marks here. Don't just write, some students will write, gas is evolved. No. Gas is evolved. How do you know the gas is evolved? That is what makes it an observation. So tell us what you see, what you expected to see to know that the gas is evolved. And the only way you can know that is by observing bubbles or effervescence or fizzing, as the case may be. Okay, so move to the next one here. It says the student filters the product from A to obtain solution H as a filtrate. All right. Now, the student divides solution H into 3 approximately equal portions in the 3 test tubes. The first portion of solution H, the student adds 1 centimeter of dilute nitric acid and a few drops of barium nitrate. Now, from your knowledge of test of ions table, you know this is a test for sulfates. Okay. This is a test for sulfates. But there is no sulfate in this compound. Our compound is what? Calcium carbonate. There's no sulfate. So your observation here will be no change. No change. Or we say no effect, basically. All right. So the second portion of solution H, the student adds aqueous sodium hydroxide, dropwise, and then in excess. So by the time you check your table of ions, we could simply go to the end of this table. You'd see there. Okay, I don't want to do that because I don't want to spend too much time on this paper. So when you go back all the way to the table, you see that when you add sodium hydroxide, because you're testing for calcium this time, you're going to have a white precipitate. Okay, because that's a test for calcium ions. Under your test for calcium ions, you see a white precipitate formed. Now, by the time it is added in excess, the white precipitate remains. So the white precipitate, remains. That is what you would see from your table. You could watch other videos on paper 6 to see how we make use of the table. So the precipitate remains. All right. Now, to the third portion of solution H, the student adds 1 centimeter depth of dilute nitric acid, followed by a few drops of silver nitrate. Of course, when you see a test like this, you simply know that you're likely testing for the halides, basically. Okay, you're testing for the halides. All right. So what will be your observation is you still have the presence of the white precipitate. The white precipitate still, that is what you observe. You still observe the white precipitate because of the addition of the acid into the whole mixture. You still have your white precipitate being produced. So that is how to go about these questions. So that is what you expected to do. You can see that they are quite easy questions to do. So you have your white precipitate in that solution still observed.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at Ajiro Tech at gmail.com, and they would reply to you, talk about your time zone, talk about, and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable, and you get the very best of service. We also have for the E levels as well, and also for the EdXL. So we have for the Cambridge E levels and EdXL E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time, even physics, for E level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you.
All right, so we go to the next one here, test on solid G. So we have a second test, so we'll simply go into this. Now, first is that it flame test is done on solid G, and then you have a lilac colored flame. So that should tell you that potassium ion is this, because when you check your flame test table, potassium ion will likely give you a purple or lilac colored flame rather. Okay, so but let's just go straight to, okay, it has to identify solid G basically. Okay, so when we also move forward to look at dissolve the remaining solid G in water to form this. Okay, we add aqueous chlorine, we have orange solution forming. Okay, so the second portion of solution G, add about this of sodium hydroxide, it remain colorless. And then to the third portion of solution G, add about 1 centimeter cube of nitric acid and a few drops of silver nitrate. Okay, so this is basically a test for the halides once again. So the one that gives a cream precipitate shows that it's a bromide ion, right? It's a bromide ion. So basically, to identify solid G, you're going to have the K plus and Br minus, and then by the time they combine together, you're going to have we're going to have KBr basically, KBr. So this is what you're expected to do in this question. Okay, so it's just straightforward. Okay, and then finally, where we have the planning of an experiment. So we have that solid sodium hydrogen carbonate reacts with dilute hydrochloric acid, and we dilute ethanoic acid. So this is reaction 1, and this is reaction 2, basically. The two reactions are endothermic, right? So when we talk about endothermic, we are simply saying that they absorb heat from the surroundings. Okay, so if you want to determine endothermic reaction, basically you are simply saying that the initial temperature can be 9. So for it to be endothermic, the final temperature will be maybe there'll be a drop in temperature, so 2. By the time you do your 9 minus 2, you're having a positive 7. So this is how you know using this calculation to determine which is endothermic. So that is the same concept we use to plan an experiment here, because it says plan an investigation to find which of the two reactions is the most endothermic. So the one that has the larger increase or larger value is the most endothermic, basically. So the plan must include how you can use the result to find which reaction is the most endothermic. And then this is what you are provided with. All right. So this is what I was able to draft out to help you. First is that you are dealing with a solid. So there are two reactions basically. So you can pick reaction 1 as a template, and then you then repeat in reaction 2, and then you do your comparison. So I'm using reaction 1 as my focus in this case. So my first step is to weigh 15 grams of, so I just assume 15 grams. You could pick any mass of your choice. Okay, so weigh 15 grams of solid sodium hydrogen carbonate into a polystyrene cup. Now, why am I using a polystyrene cup? I'm trying to observe temperature changes, and I also want an accurate measurement. So a polystyrene cup, like we said, prevents heat loss. So I'm able to get an accurate measurement of temperature. All right. So the polystyrene cup is the most suitable experiment so suitable apparatus or vessel for this reaction. So weigh 15 grams of solid sodium hydrogen carbonate into a polystyrene cup. Then I will measure 70 centimeter cube of dilute hydrochloric acid using a measuring cylinder. So I have to state the apparatus I'm using for each step. We've said that from previous videos on how to plan an experiment. So after doing this, then I would ensure that I measure the temperature of the acid using a thermometer before mixing them. So it's important that you get the initial temperature of the reaction before you even start mixing anything. That is a very important step. And then my next step will be to pour the acid I have measured into the polystyrene cup and mix the reagent using a glass rod. Or mix them together, all right, after I've taken the temperature and I've documented that somewhere, I'll mix them together and I'll stir the mixture using a glass rod to ensure that they mix properly. Then, after the reaction has mixed properly, I would measure the temperature of the mixture. So I'll take the temperature again after mixing using a thermometer. All right. So these are the steps I'll take for the first reaction. Then I'll repeat these same steps using ethanoic acid. So instead of using hydrochloric acid, I'll repeat the same steps using ethanoic acid for the second reaction this time. Then I'll compare both of them. The reaction with the biggest temperature decrease is the most endothermic, right? So we say that one has absorbed more temperature than the other. So this is how to plan to get the 6 marks for this question. Okay, and that brings us to the end of this video. I try to make it as short as possible so that you can get the information as fast as you can. So I will encourage you to watch every of our videos, every other videos I make, okay, so that you can learn and get excellent results in your, whether it is May, June, February, March, or October, November. Thank you for subscribing, and please share with your friends.